Light travels at a finite speed, approximately 299,792 kilometers per second, 186,282 miles per second in a vacuum. While incredibly fast, this speed is not instantaneous, meaning there is always a delay, but this delay creates a fascinating consequence. When we look at distant objects, we are seeing them as they were in the past, not as they are now. The farther away an object is, the longer its light takes to reach us, meaning the more outdated the image we see. The light from the sun takes about 8 minutes and 20 seconds to reach Earth. If the sun were to vanish this instant, we would still see it shining for over 8 minutes before its disappearance became apparent. Imagine watching a live broadcast from Mars. Due to the time it takes for signals to travel, what you see on the screen happened minutes ago. Light behaves similarly. It's like watching a delayed transmission of the universe. The finite speed of light turns our telescopes into time machines. When we observe a star 1,000 light-years away, we're seeing light that left the star 1,000 years ago. By the time the light reaches us, the star could have undergone significant changes or even ceased to exist. For nearby objects, this delay is negligible, but on cosmic scales, it becomes profound. The Andromeda Galaxy, visible to the naked eye, is about 2.5 million light-years away. When we observe it, we see it was 2.5 million years ago. Any events occurring there today will not be visible to us for another 2.5 million years. It's like reading a letter from a distant friend. By the time the letter arrives, the events described in it have already happened. Observing distant galaxies works the same way. The light we see is like a cosmic letter written millions of years ago. Because light takes time to travel, we can never observe the present state of distant objects. The universe we see through telescopes is a snapshot of its past. Even for relatively nearby stars, there is a delay of years to decades in what we perceive. For galaxies billions of light-years away, we are seeing a version of them that existed when the universe was much younger. The James Webb Space Telescope captures images of galaxies that formed over 13 billion years ago, shortly after the Big Bang. While these observations reveal the early universe, they tell us nothing about how those galaxies look today. This is like looking at a photograph of a person as a child. You can understand their past, but you have no way of knowing what they look like in the present moment. The limitation of light speed presents challenges for real-time communication and navigation in space exploration. For example, signals sent from Mars to Earth take about 13 minutes to arrive, meaning real-time control of Mars rovers is impossible. The Voyager 1 spacecraft, over 20 billion kilometers away, sends signals to Earth that take more than 20 hours to reach us. Any command we send to Voyager also takes 20+ hours to arrive, making immediate responses unfeasible. It's like trying to steer a remote-controlled car, but every command you send takes hours to reach it. By the time the car reacts, it has already moved far from where you intended it to go. The observable universe is limited by the distance light has traveled since the Big Bang, about 13.8 billion years ago. Galaxies moving away from us faster than the speed of light due to the universe's expansion are effectively invisible. The finite speed of light shapes our understanding of causality and relativity. Events cannot influence each other faster than the speed of light, ensuring that cause precedes effect. A hypothetical warp drive that allows faster-than-light travel would break the causality barrier, potentially allowing an astronaut to arrive at a destination before they even left. The fact that what we see is a relic of the past forces us to confront a philosophical truth. Our perception of the universe is always outdated. The universe we observe may be vastly different from its current state, raising questions about the nature of reality and how much we can truly know about the present cosmos. When we look at distant stars, they might already have exploded into supernovae or collapsed into black holes. What we perceive is their ghost, a memory carried to us by light. It's like watching a delayed replay of a sporting event, believing you are seeing it live. What you perceive has already happened, and the true result is already known to those closer to the action. No matter how advanced our technology becomes, the speed of light imposes a hard limit on how quickly we can observe distant phenomena. Future technologies might help us infer present states by modeling changes over time, but direct observation of the present remains impossible for distant objects. Astronomers use simulations to predict how galaxies evolve over billions of years. These models fill in the gaps between what we observe, the past, and what might exist now. This is like predicting the weather. While you can use current data to forecast the future, you can't know with certainty what the weather is like on the other side of the planet in real time. Understanding the limitation of light speed is crucial for fields like astronomy, space exploration, and physics. It helps scientists design telescopes, spacecraft, and communication systems that account for time delays and light travel distances. The Event Horizon Telescope captured an image of a black hole by piecing together data from multiple observatories. This effort relied on understanding the time it takes for light to travel from the black hole to Earth. This is like reconstructing a puzzle from scattered pieces. Each piece arrives at a different time, but knowing the delay helps you assemble the full picture. The limitation of light speed shapes how we experience the universe. Everything we see is a glimpse into the past, and the present state of distant objects remains forever out of reach. While this constraint may feel limiting, it also opens a window into the universe's history, allowing us to study its evolution and uncover its mysteries. The Hubble Space Telescope revealed galaxies as they appeared billions of years ago, giving scientists a clearer picture of the universe's formation and growth.